Building a nuclear power plant often spans 5 to 10 years, which can accrue significant financial costs, depending on how the initial investments are financed. Because of this high construction cost and lower operations, maintenance, and fuel costs, nuclear plants are usually used for base load generation like hydropower plant. A nuclear power plant uses the heat generated from controlled nuclear fission to produce steam. Now understand the nuclear fission process. The process is often initiated by a neutron striking a heavy nucleus, such as uranium-235. The fission also releases several new neutrons, on average around 2.5 for uranium-235. The collision causes the nucleus to become unstable and split into two smaller nuclei, known as fission fragments. A large amount of energy is released, which comes from the mass defect, the mass of the fission products being less than the original nucleus. This energy is released as kinetic energy of the fragments and as electromagnetic radiation. Once process started, then it automatically running this reaction called nuclear fission reaction. This reaction occurs at a speed of 20,000 km per second. To control the speed of fission reaction, we put heavy water and use of control rod made up of graphite. First, all the uranium set into small pellets. After this, pellets put into a zirconium alloy tube. Then make a big bundles of this kind of tubes. Zirconium tube temp range is in the between 1800 degree to 4500 degree, but in front of uranium this is very less. All this bundle put into the nuclear reactor core. After that, heavy water is stored in the reactor. Heavy water acts as moderator. Here the chain reaction occurring is controlled by the graphite rods. After all this nuclear reactor is completed, closed, around the reactor 2 meter thick concrete wall is made so that radiation should not mix with the environment. The system has to separate water loops, the primary loop, which circulates pressurized water through the reactor core to absorb heat, and the secondary loop, where steam is generated to drive a turbine and produce electricity. The heat transfer creates high-pressure steam in the secondary loop, which is used to spin a turbine and generate electricity. This electricity is transferred to long distance through transformer. The condenser cools the low-pressure steam that has passed through the turbine. This heat exchange process converts the steam back into liquid water.